Hey guys, let's dive in here. We are starting Unit 5. We're moving on to something new. This is a unit called Polynomials. What the heck is a polynomial? We're going to see shortly. Here's some examples right here on this front page. Polynomials are, in a sense, just repackaging things you already know. A lot of what you've already learned and worked with is in this unit. We're just giving it a new name, kind of going over it, putting it together to make sure it's all there for you. Before we talk about polynomials, let's start with monomials first. What is a monomial? A monomial is just a number, variable, or both. Together in a single term. This is something you've already worked with a lot. Examples are things like -5. That's a monomial because it is a number. Or how about x squared? That's a monomial. It's a variable. And anything in a monomial can have an exponent. It can be raised to a power, to the 5th or the 12th or whatever. Not any kind of fractional exponent, which we learned last unit brought in radicals, and not any negative exponents. We can't have anything move to the bottom of a fraction. So these are simple exponents. Whole number, positive. So -5, x squared, put them together. Something like -9, x cubed. That's another monomial. It's just a number or variable or both. And we can get big. You can have something like -23, x to the 4th, y to the 3rd. There you go. That's all a monomial. It's just a single unit number variable. What about a binomial? Before we do that, let's go back. Notice what we call these, a monomial. What does mono mean? Mono means single or one. Now let's go down the list, and I bet you'll figure out if a bi, I should actually just use bi. If bi is on the front, what does bi mean? Bi means 2. So what do you think a binomial is? It's just 2 monomials being added or subtracted. And I'm having some problems with my pen. Okay, examples here are just some of those from above. I'll take the first two, -5 plus x squared. That's 2 monomials. Together they're a binomial. Okay. Take the next two. -9 x cubed minus 23 x to the 4th, y to the 3rd. There's another binomial. There's 2 of them together. And again, just to be clear, that's a binomial. That's a binomial. Okay, they're separate. It's 2 monomials, or what we've been calling terms up to this point. A monomial is just another name for a term. You guys have been working with terms all this year so far. They're interchangeable. So 2 terms, a binomial, single term, monomial. And trinomial. I'm sure you've got it at this point. We talk about tri, as in tricycle. That means 3. So we know what a trinomial is going to be. 3 monomials. Added or subtracted. Okay, examples. 5x squared minus 7x plus 8. There's a trinomial for -13. We can use other variables besides x and y. -13p plus 14m squared minus 11. Okay, those are trinomials. They have 3 terms each, 3 monomials, and each one's composed of numbers or variables. All right, what's this idea of a polynomial? Well, a poly, we'll talk about poly, just means many. And I need to learn how to spell, evidently. Many of something. So polynomial just means many of something, and a polynomial includes all of these. Okay, polynomial is the term that overarches everything. So a monomial is technically also a polynomial. So is a binomial, so is a trinomial, but it also includes things that are bigger. Okay. Okay, that's got 4 terms in it, or 4 monomials. So technically it's a polynomial, and from that point on, 4 or more, we would just call it poly. We don't try to name each one. The specific names are just monomial for 1, binomial 2, trinomial 3. Everything else is poly, but poly also is the overarching name for everything. All right. Real quick, what are each of those called? Should take you about 10 seconds. Pause this and go. Okay. We've got a binomial there. We've got a monomial there. We've got another binomial there, and we've got a trinomial there, and of course all of them together are also known as polynomials. All right, let's start working these. Okay, how to write your polynomials. In addition to having a naming convention for them, there's also a way we need to write them. Now, this is not mathematically right or wrong. If you didn't write them in this way, I wouldn't take off points unless I'm specifically asking you to write something in this way, like on a quiz, then you'd need to. But if you don't get this right on any given problem, I'm not going to mark it wrong. It's just a way to develop a habit. Makes it easier for people to read your work. Okay, and that is anything with the whatever has the highest exponent is going to go first. Okay, so x to the 4th is going to go first because it's got the highest exponent. As I look through, the next highest exponent is an x to the 3rd, so I'm going to bring that one next. And I keep looking, and now the remaining 2 here don't have exponents. What you choose between those is always variables first. So that 12x is positive plus 12x. And always what comes last is your constant. Okay? And this is called standard form. So to be clear, highest exponent first, and then descending, that means going down from biggest to smallest. Okay, highest exponent first, and it descends from there. And then the constant, which is a term with no variable, is always last. Okay, so let's do that second one and see this again. I'm looking for my highest variable. It's right there. So I'm going to rewrite this in standard form as the 8x cubed minus the 17xy squared. And notice, another point to notice here. The cube there's on the x, the squared is on the y. We're not comparing, we're not trying to order them by their specific variable letter. We don't care. We're just going highest to lowest on their exponent. And then lastly, the -6 xy. And as always, also remember, the sign goes with the term or with that monomial, always, okay? So keep that sign with whatever's behind it when you reorder things. Those are now written in standard form. So when you're doing work on an upcoming quiz, that's how you'd want to write each of your answers after you're done with some adding or subtracting, combining like terms, whatever it tells you to do in the problem. That's how you'd want to write your final answer, is in that descending order called standard form. Also, notice it has nothing to do with the number coefficient up front. Okay, we're not looking at these. The number 1, the invisible 1 in front of the x to the 4th, is not what we're ordering by. We're not looking at that 1 or the 8 on the 8x cubed. We are looking at just the exponents, okay? So ignore any of those coefficients, just use your exponents. All right, why don't you rewrite those into standard form and tell me what they are in terms of size. Monomial, binomial, trinomial, go. Pause it. All right, let's take a look. This one I'm going to rewrite as the 9x squared first, and then the minus 12. Real easy. And that is a binomial. Second one, that negative 3x squared is first. Then I go to the next highest variable, which is the negative 27x, that term. And finally, my constant, plus 19. 3 terms there, that's a trinomial. Okay, next, getting a little bigger. There's my y cubed, that's my biggest exponent. Then I've got a squared, so I'll go with that for the minus 11 x squared y. Now with what's left, they both, what's remaining, they all have no exponents, so that's an exponent of 1. But remember, go with the variable first, minus 17x, and then your constant last. And there are 4 terms here, which means we call him a polynomial. There we go. Polynomial. All right, simplifying polynomials. This is actually review at this point. This is entirely stuff you guys have done, okay? We're just putting together like terms. We've already done this before a bunch of times. Now, what to watch for with these like terms? First of all, an xy squared. Notice the square is on the y. Okay, that is not the same as what's right next to it. Notice the square's on the y. What's right next to it has the square on the x. So that other term is entirely different. X squared y is a different, unlike term. Those guys cannot combine with each other. You have to watch those details. When we talk about like terms, and there's multiple variables, they have exponents they're raised to, we literally are looking for identical, okay? Second, and I'll show you this in a second on the examples, the second thing to watch out for, when you're canceling terms out. If I'm combining things and I've got an x squared and an x squared, those are like, they combine, and they end up with coefficients, a negative 6x squared, a positive 6x squared. That's going to zero out, okay? That's a 0x squared, and a 0x squared is nothing. It's gone, okay? It just cancels. There isn't anything that comes out of that. What I will sometimes see kids do, I've often seen kids do, especially in systems of equations, I will see this kind of a thing, okay? Negative 6 and 6 cancel, but somehow the x squared is going to be there, but it's not, because that negative 6 and 6 canceling leaves a 0. And what's 0 times anything? They're stuck together, they're multiplying. So the 0 cancels and kills off the x squared as well, okay? So this whole thing cancels, it goes away. There's no x squareds left, they'll drop out of the entire problem. Let's look at these examples. Okay, I've got some y's and I've got some constants. If I'm simplifying, I'm just putting things together. 5y and negative 5y. There's an example of what we're just talking about. Those both cancel. All I have left is my negative 11 and 14 is 3. And that's it. So the simplifying there resulted in a 3. We want to write our answers in standard form as well, but there's not much to order when all you have left is one term, 3. All right, next one. I've got some x squareds here, so I'll put those guys together. And that's an 8 and a negative 11, which is a negative 3. This is our integer skills we always use. And remember, like terms, an x squared and an x squared are going to stay x squareds. In fact, let's just jump up here for a sec and review that. If I said 3x minus, let's do plus, it's easier, plus 5x, remember, this is all we're talking about. We're just saying I have a group of 3x's and a group of 5. We're adding them together, okay? We've just got a total of 8 x's. So nothing's going to change here between the type of item. We just have a total of 8 x's. If I were to make those squareds, nothing changes there. It just means I have 3 of this item called an x squared, and I'm combining with 5 of an item called an x squared. So all I'm doing is counting up how many total are in my group. When I count up all those x squareds, I see that I have 8 total of the x squareds. Okay? It's super important for you guys to see x's and x's. They just make more x's. We're just adding the coefficients or subtracting the coefficients. X squareds and x squareds just make more x squareds. All we're doing is adding together those coefficients. And notice it really doesn't matter. I could throw a y on the back of these. As long as they're still like x squared y's and more x squared y's, it's still just adding 3 of that type and 5 of the other type. As long as they're like, I'll end up with 8 of that x squared y type of term. Okay? So let's go back up here and apply that. There's my negative 3x squared from the 2 original. Now put together my x's. Don't forget, signs go with those terms. So negative 5 and negative 3, I've got negative 8 of the x's. And notice the way that I solved it. I really wasn't intending to, but having done this for so long, I automatically solved it into standard form. Okay. When I'm solving, the habit I built, and I would recommend you guys do the same thing, is start by looking for the highest exponent. And so I'm going to start solving the problem with that term. And then I'll go to the next highest exponent, and I'll kind of organize it as I go. It automatically is in standard form when I finish, because the x squareds are in front of the x's. If you happen to solve it in another order, just rewrite it when you're done. So it does say negative 3x squared minus 8x. All right, last one. I'm looking through, and I'm going to start with my squareds. Just start with writing it in that standard form. And these are both the same, x squared y, so those will combine. And I've got negative 9 plus 11. It's going to give me 2 of those. Now I'm going to continue looking. There's some xy's, there's some xy's, so I'm going to do those next. I've got 23 of them, and I've got negative 14. So if I'm going to combine 23 and negative 14, that's just straight up subtraction like I'm doing over here, which gives me 9. And there are more good guys, so it's a positive 23, so it's a plus 9. Then I see over here at the end, there's a minus 9 that's left. It's by itself, so there's nothing to combine with, and it's also a constant, it's got no variable, so it's going to go right at the end. And I'm done. I simplified the polynomial, and it's also written into standard form. It goes from the highest exponent down with the constant at the end. Okay, go ahead guys. Simplify those 3 real quick, and make sure to write your answers in standard form. Go. All right, let's jump in. Kept it easy for you to start. This is pretty much review at this point. 5 minus 11, negative 6. X's go with x's. There you go. Negative 13 and 7. That's going to be 13 minus 7 is 6. More bad guys. -6. Written in standard form in descending order. There you go. Number 2, x squared and x squared. Put those together. -9 and 6 is -3 of the x squared type. And now we've got 11x next. And now I just got that -14 written in that descending standard form. There you go. Number 3, a little bigger numbers, but principle's exactly the same. xy squared. I do have some more xy squareds. There they go. 41 and -7, so subtract 7 off that 41, so 34. Go to my next. What do we got? 13x plus x. What's there if we don't see anything? Don't forget your invisible 1, so that's actually plus 14x. And there you go. Simplified and in standard form. All right, here you go. Your practice homework problems at the end. A few problems to write in standard form and name each. Okay, name it as a monomial, binomial, trinomial, polynomial. And then some simplifying, and also make sure you write them into standard form. Pretty easy kind of step into this first section of the unit, I think. I'll go ahead and fill in those answers for you, and I'll just pop them in for you in a sec. All right, there's the solutions to each. Those first 3 written in standard and what type they are. On these other 4 practice problems, let's see here. Those guys cancel, the 8x and -8x, so all you're left with is those 2 constants. They add to 25. Number 2, I just put them together color-coded with x squareds. Then I put together x's, then I put together the constants, so it's in standard form. Number 3, those x5s, they cancel out. The x squareds go together, and then I noticed at the end I had an x cubed, which means I had to rewrite the problem into standard form to put those x cubes in front of the x squareds. And last one, there wasn't anything here for that xy cube, so it just goes to the answer. And then I combine the other like terms, and it's finished in standard form.